such a nice time, been so well looked after by Vincent and Sarah. You know, this is a special time, I think, in terms of where psychedelic science, psychedelic research is at the moment. And, you know, being invited to the launch of the French Psychedelic Society was something that was quite, you know, easy to say yes to, because I have to be honest, I've noticed that you know, generally France has been missing from to some extent from some of the developments that have been happening over the last, I guess, 15, 20 years. And it just seems important, you know, that especially given historically where French researchers were in terms of psychedelic science, it just seems right that you really, you know, come back into this in a strong way and join the party, because these are good times. They're great times. One of the reasons why they are so good is that now we're revisiting this topic with greater maturity, greater sophistication. I think it's fair to say some of the stigma that we've heard about today, I wish I could understand it. I can't speak French, I'm afraid, for my sins. But some of that stigma, I think, has washed away, because a lot of it was nonsense. You know, there was so many myths that were put forward about psychedelics, but now we're looking at them with fresh eyes. In a way, we've had a reset, we've had a kind of reboot, and we can look on things with greater clarity, and that sort of process can be quite a useful analogy for thinking about the mechanisms of psychedelics, how they work on our minds and our brains, and how they may be useful therapeutically. So that's going to be the focus of my talk. But before I begin with the good stuff, just to summarize very briefly, because a lot of this will be just sort of, you know, old news stuff that you're very familiar with. But it's important for perhaps the few in the audience that might be here who just want it broken down, you know, right to the basics. What are psychedelics? And so when we talk about psychedelics, when I refer to psychedelics, I'm referring to the classic psychedelics. These are compounds that share a particular pharmacology. They work on the serotonin system in a particular way. Some key examples, not by any means an exhaustive list, but still some examples of important classical psychedelics here. 4-hydroxydimethyltryptamine, psilocin. It's the active metabolite of psilocybin that you've heard so much about today. It's the compound that works on the serotonin system. When psilocybin gets into our bodies, it's broken down. It's psilocin that activates serotonin receptors in a particular way that accounts for psilocybin's subjective effects. Dimethyltryptamine, found in ayahuasca, first discovered in 1931 and then in 57 in ayahuasca, being used in the Amazon. For example, LSD, the prototypical psychedelic, its psychoactive effects famously discovered by Albert Hofmann in 1943. And when you look at these compounds' molecular structures, what's quite striking, what should be striking, is that they share a common molecular backbone to what you'll see in a very important neurotransmitter and neuromodulator in our brains, serotonin. A neurotransmitter, a chemical messenger that is involved in a range of very important functions, from cognition to mood to sleep to states of consciousness. And again, an interesting thing is that psychedelics, to a large extent, catalyzed our understanding of serotonin. Its very existence in the brain wasn't discovered until 1953, well after, you know, a decade after LSD's been discovered. So these developments, generally in pharmacology, actually sit in parallel to some extent. What happened after the, you know, mid to late 1960s is a different matter, but at least if we rewind to this period, psychedelics are very much a part of biological psychiatry. They're helping biologically minded psychiatrists realize that serotonin is important, that it's probably implicated in psychiatric disorders. And so, you know, where we are right now, I think, is at this interesting transition point where we're trying to bring psychedelics back into the mainstream so that they can inform on generally important topics like what does serotonin do, how does the brain work ordinarily. These are topics that aren't so psychedelic-centric. They're very general and very important and fundamental. They're very basic. Psychedelics are merely tools for understanding the mind and the brain, and that's how I see these compounds, and that's why I believe they're so important and powerful and underutilized for science. So again, with some basics, the pharmacology of psychedelics, serotonin, it should be said, is a particularly complex neuromodulator. Unlike several other neuromodulators that you'll have heard of, like dopamine, serotonin has a whole load of different receptors. What are receptors? They're kind of locks, if you want. There's a common key, that's serotonin, naturally. But these are kind of locks. They're all slightly different from each other. They sit on neurons in the brain. Serotonin comes in for the serotonin locks, the serotonin receptors, and it activates these receptors. And these receptors often do quite different things, and sometimes they actually do opposite things to each other. So this complexity confers a functional complexity in this particular system. And that's why serotonin has remained such a mystery in pharmacology. Other neuromodulators, like dopamine, arguably have been much better characterized, but serotonin, what it's for, what it does, has really largely remained a bit of a mystery in neuroscience. The association between psychedelics and their effects on serotonin was first thought about, written about in the early 1950s, so very early after serotonin itself was found in the brain. But a key milestone in terms of our understanding of the pharmacology of these compounds occurred in the mid-1980s, where an American pharmacologist, Richard Glennon, discovered that the affinity, the stickiness, the ability and the strength by which a psychedelic binds to a particular serotonin receptor, the serotonin 2A receptor, correlates very strongly with a given psychedelic's potency. So if the affinity is high, if the binding potential binding is strong, then that psychedelic will be especially potent. So for example, LSD, very high affinity for the serotonin 2A receptor, you only need tiny amounts because it's so potent. So this rule has remained a very important staple finding and principle in our understanding of how these compounds work in the brain. Whatever other very rich and complex subjective effects these compounds might produce, challenging even our belief systems, we can still bring it back to a particular protein, the serotonin 2A receptor, sat on neurons in our brains that we know is key for how these compounds work. We also know that because if we give compounds that selectively bind to this serotonin receptor, the serotonin 2A receptor, and block it, then you give a psychedelic, the psychedelic won't work. You won't visit these astral realms and start questioning your beliefs in materialism and such like. So, this is a very grounding principle about what psychedelics do, and that they do work on our biology. They work on this thing of nature, which is our brains. And so, what do we know about the serotonin 2A receptor? Well, we know more in recent years than we've ever known, and that's because some of the labeling approaches in neuroscience have improved quite substantially. We're able now to label these receptors in what's called their high affinity state, or their active state, their functionally active state. And when we do that, and you can see a map of where these receptors are, this is a kind of heat map in a way, where the colors are hotter, that's where the receptors are most densely expressed. And what we found is that the expression is highest very much in the cortex. That's something that we've assumed for a while, but now with greater resolution we can see that particular aspects of the cortex have higher expression than other aspects. For example, the motor cortex here, relatively less than the high-level associative cortex. This particular region is interesting in the context of psychedelics, and it's just interesting anyway, the posterior cingulate cortex, because it's implicated in very high-level psychological functions, things like self-reflection, what's called mental time travel, the ability to project ourselves in our imagination into the future, think far into the future, look back into our past and beyond our personal past. Indeed, the ability to imagine in general, or what's sometimes referred to as counterfactual thinking, is associated with this region and this system or network that this region belongs to. It's called the default mode network. It's a network that's captivated the imagination of cognitive neuroscience for the last 15 years or so. And it's likely very important that the key receptors, the necessary receptors that psychedelics work on, are expressed in this particularly high-level network in our brains. What else is important when thinking about this serotonin 2A receptor? Well, a principle that I'm going to introduce to you that's quite simple, but I would want to submit is essentially important, is that it mediates plasticity. And we could think of plasticity in quite a formal biological sense. We could think of neural plasticity, neurons adapting, growing new synapses, or even growing themselves. Or we could think of plasticity in a more generalized sense, where we could think of functional plasticity. And so essentially this is the ability, not just of the brain, but of the mind, which of course is intimately related to the brain, as being able to change. So that's the working definition here of functional plasticity. It's simply the ability of the mind and the brain to change. And the principle here is that the serotonin 2A receptor is critical. It plays a critical role in creating conditions in which the mind and the brain are able to change. We'll revisit this throughout this talk because I think it's a very important principle. So let's go into some of the details. You'll see a lot of references here. Don't panic too much. They're just there in case you want the slides, and I've given the guys my slides so you can look these up. But it's important to put here because it shows that there's an evidence base to these ideas. The take-home principle is that the serotonin 2A receptor is associated with plasticity, so we'll go into the details. What do we have here? Serotonin 2A receptor agonism, which means stimulation, it means activating these receptors, has been associated both with learning, especially low-level learning, associative learning, and also unlearning or extinction learning. So, for example, unlearning a practiced behavior, perhaps a behavior or a way of thinking that's become entrenched. You might think of that in the context of addiction, for example. So unlearning these associations. Serotonin 2A receptor agonism and stimulation being associated with neurogenesis, the generation of new neurons and functional components of neurons, especially in the cortex. The evidence around the hippocampus is a bit more variable, but in the cortex, there's one particular study showing a doubling of a marker of neurogenesis in the cortex. Also, critical periods. What are critical periods? There are periods in our lives in which we are most sensitive to change. So, for example, in infancy, when we're so supple in mind, but also going into adolescence, a key period of pruning in the brain. 2A receptor expression is much higher in the young brain than it is in the older brain. Let's see some pictorial evidence of that. You can see these PET images here. Again, these are kind of heat maps. The hotter the color, the more expression. We can see a 21-year-old brain on the left there, and then a 68-year-old brain on the right. So the kind of conditions, if you want, the biological conditions for plasticity and change are very much there in the young brain and comparatively less so in an older brain. Also, serotonin 2A receptor agonism or stimulation is associated with the desegregation of modules. So what are modules? They're systems that do specific things. They're specialized for specific things, like vision, for example. So what does desegregation mean? You could think of it as synonymous with a de-specialization. So the difference between these systems becomes less under a psychedelic. Why is that relevant? Because when you look at the brain through development, it moves in an opposite direction. It becomes more specialized, it becomes more segregated. Systems start doing specific things, and they do those things with finesse. But what happens under a psychedelic is the mind and the brain becomes more supple and crucially less specialized, more generalized under a psychedelic. So what's the take-home message here as well? It's one of a kind of functional regression, if you want. So what the brain does normally during development, here we're seeing it kind of resetting to an earlier condition under the psychedelic, physically under the psychedelic, not necessarily afterwards. If it was afterwards as well, we might worry more about psychedelics than perhaps we should. What else is there to really digest that's an important principle? Here the take-home message is that stress has been shown to functionally upregulate the serotonin 2A receptor. So, for example, a particular variant in the serotonin 2A receptor, a particular genetic variant that expresses the 2A receptor, and a particular one that's associated with more signaling at the 2A receptor is also associated with greater sensitivity to the environment. How do you test that kind of thing? Well, you can separate rats in terms of whether they have an enriched or stressful early life period. You can do it in humans as well. Look at people who have traumatic backgrounds or a comparatively enriched environmental context. And then you can look at how this serotonin 2A receptor gene mediates the outcomes of those conditions further on. Also, it's been shown in controlled studies that early life stress, again, it will increase both expression of the serotonin 2A receptor and also its functioning, its signaling. Also control studies showing increased functioning at the serotonin 2A receptor, and also that the serotonin 2A receptor mediates behavioral responses to induced stress, usually driven through the induction of volatility in the environment, so unpredictability in the environment, another topic that will come in as we go along. So again, take-home messages, what do we have here? The suggestion, evidence-based suggestion, is that environmental volatility may tune up or induce stress, which in turn tunes up serotonin 2A receptor functioning. Why would that happen? Because in conditions of volatility, uncertainty, it may serve us well to be adaptive, to be able to think and behave more on our toes. Okay, so those are some important pharmacological principles, some kind of low-level grounding for our understanding of what psychedelics do to the mind and the brain. Let's now have a look at some of the brain imaging, the functional brain imaging findings that exist in relation to psychedelics. So I'm just going to summarize here again and try and tell you about three principles. And the first one is one of disintegration. So this is disintegration of systems or networks in the brain. It should be said that, thankfully, the way we're now thinking about brain function is moving on from a modular characterization of the brain, where this region does this. It's a kind of simplistic way of thinking of the brain. And now we're thinking about more how distributed systems or networks in the brain subserve different functions. I think it's a more intuitive and accurate reflection of how the brain works. So here we're looking at a particular system. It's a system that's part of the default mode network. We're looking at this region here, the parahippocampus, and asking a simple question: how does it talk to the rest of the brain on placebo and on, in this case, LSD? And what we find with this light blue region, that's depicting regions in the brain, looking in the whole of the brain, that talk less with the parahippocampus under LSD. What does this mean? Well, we plotted it against some of the subjective effects of LSD. We found a relatively selective relationship with this particular aspect, ego dissolution. So we looked at other things like perceptual changes, but the relationship with ego dissolution was strongest of all, and we found that the greater the ego dissolution under the LSD, the greater the decoupling or disconnect in this particular circuit of the default mode network. What does that mean in a broader context? Well, it might tell us that this circuit is important for the maintenance of our sense of self or ego. If that splits, if that disconnects, then maybe we begin to break down as selves, as egos. Let's go on to another drug, DMT. Here we're looking more at a temporal disintegration. These are rhythms in the brain up on the y-axis here. Faster rhythms at the top, slower ones down the bottom. This hot band here is showing us that a particular rhythm in the brain, a particular oscillatory rhythm, is especially pronounced in the brain. People have their eyes closed here. When they close their eyes, alpha, this is the alpha band, is especially prominent. What other conditions is the alpha rhythm especially prominent? Well, it is more prominent in humans than other animals, and it's more prominent or pronounced in adulthood than it is in infancy. So like the default mode network, which importantly, it has a relationship with alpha and default mode network activity having a positive relationship, it may be a signature of the high level quality of cognition or consciousness that humans, I was going to say enjoy, but let's just say have. So what happens here? We inject the DMT, it comes in at time 0. This white trace here is showing the intensity of the subjective effect. You can see they rocket up over the period of about a minute, close to peak effects. So we inject the drug in as a bolus, following Rick Strassman's protocol and American research. He's done a lot of important work on DMT. 2 minutes, 3 minutes are around about peak effects. If we had plotted the 0 to 10, at the higher dose, most people just hit the ceiling, which is a rating of 10 out of 10 for intensity, if they can even get the rating out. They give these every minute, and that's how we make this curve. This is useful because it allows us to see that the normal rhythms of the brain essentially just disappear when people enter the DMT state, and then they report weird and wonderful things afterwards when they can talk and they remember that they're a human being and they've taken DMT. And they say things like, there were shadows of presences taking care of me, moving at great speed around me and chanting. So remarkable phenomenology that you see with this compound when it's given in this way. And then as the effects fade and the intensity starts dropping, back comes this familiar old alpha rhythm, and the brain kind of resets back to normality. But at least in the thick of the DMT state, the psychedelic state, you've got a disintegration, temporal disintegration going on. Some interesting questions to follow on about an emergent order that may come in amidst the general chaos or entropy disorder that occurs and seems to characterize the psychedelic state. So that was only one principle. So let's try and move on a little bit more swiftly. We've got a second one here of de-differentiation, de-specialization, desegregation. These are all synonyms for essentially the same thing. Instead of putting a negative spin on it with a D, let's just refer to it as a positive. You could call it a global integration. This image has proved quite popular because it kind of shows that beyond words. You see the brain at baseline, and these are essentially systems where activity is coherent. Ordinarily, believe it or not, there's a similar number of connections in these two images, but most of the connections at baseline under normal conditions are local. They're within systems. Let's imagine that this is the visual system, for example. Most of the regions within the visual system, and you can see the same thing here, I'll go on to that in a minute, are talking within the system. It's a kind of clique. It's doing most of it, it's like at a party, it's mostly people who know each other, they're just talking to each other. Look at this party. Everyone's talking to everyone here. And so it's a nice, it's almost a metaphor, even though it's literal, of what psychedelics do to the brain. So this global integration or despecialization, desegregation. We can see it in another case here. This was with psilocybin, magic mushrooms. This is with LSD. This is baseline. What's the blue bit? That's the visual system. It's actually the primary visual system. which we've mapped out using brain imaging and showing people very simple geometric patterns, and then identifying this region is called V1, primary visual cortex. And then we ask the question where in the brain talks with this blue region, and we find that most of the conversations are going on in this kind of visual clique. The visual system is doing vision. Under LSD, all of a sudden, much more of the brain, if not the whole of the brain, is contributing. If you want, you can make this inference to visual processing. So this might explain how other sensory modalities and even imagination can start to bleed into the visual experience under psychedelics. So we've done 2 or 3. Here's the third one. I call it the entropic brain, born out of a number of different principles of how the brain works. Carl Friston's free energy principle, the Bayesian brain, and Giulio Tononi's work as well. But it's a way of describing how psychedelics are working, and I've recently revisited in a review paper. Essentially, it's saying that normal waking consciousness inhabits a zone, and sedatives and anesthetics can drop you down in that zone. They can drop you down into unconsciousness, deep sleep, brain injury, pathology can drop you down into unconsciousness. Brain activity becomes less complex, more predictable, less entropic under anesthetics, under deep sleep, in disorders of consciousness. Interestingly, in sleep, you get this return to near normal waking consciousness levels of complexity. And psychedelics, we found recently, tunes the brain up in the other direction. And to my knowledge, to our knowledge, this is an anomaly. And this is where, you know, psychedelics can speak to people who perhaps never had a psychedelic experience, but they're shown something that makes them think, oh, you know, that's unusual. Where, you know, they, for example, know about measures of brain complexity or entropy, like the ones that are being applied here, and they see this anomaly, and that makes them think, oh, maybe psychedelics do something quite interesting to the brain and the mind. I'll introduce the idea of criticality, the principle of criticality later on, but psychedelics appear to move the brain up into more complex brain activity, more entropic brain activity than normal waking consciousness. What does this mean? Well, the entropic brain principle idea is that there is an intimate relationship between the complexity of brain activity and the content of brain activity and the content, the richness, if you want. I think rich is a good bridging term. The richness of brain activity relating very intimately with the richness of conscious experience. Psychedelics moving the brain in terms of greater richness of conscious experience, anesthetics and deep sleep moving it down into less content and eventually into unconsciousness. Maybe with high doses of psychedelics, and perhaps psychedelics given in certain ways, perhaps a compound like 5-methoxy-DMT may push the brain into a zone where, at least in terms of conscious report, the experience is so beyond that people either can't remember what they experienced or content sort of evaporates almost. And it's a bit of a question mark about what actually happened. Let's try and break this down, because I've talked about a lot of it, but let's just concentrate here now. This is some work, collaboration with Giulio Tononi, looking at disorders of consciousness down into the vegetative state, where complexity, broadly speaking for simplicity, is abnormally low. This is locked-in syndrome, which essentially is comparable to normal waking consciousness. People are paralyzed, they can't move, but the content of their consciousness is as rich as it is in people with no pathology while awake. And so there's this, you know, I think it's worth asking this question. I've heard others ask it, and so why not, you know, just put it out there and test it in people, you know, for whom there aren't many options in terms of disorders of consciousness. People explore things when things are desperate, like invasive approaches like deep brain stimulation. And so what of the possibility, if there is this rule, that there's an intimate relationship between complexity of brain activity, or richness of brain activity, and richness of conscious experience, that we could push it up with a psychedelic. How you get consent, the whole ethics around that is worth thinking about, but the same situation arises with deep brain stimulation for disorders of consciousness. Sometimes things are just worth testing because the outcomes can be positive, and that's a nice segue really onto the therapeutic potential of psychedelics. You can see the therapeutic context here. This is the Hopkins team sitting with a patient. This is where they do, at least they have in the past, most of their therapeutic work. I've been in that room. It's smaller than it seems in the photos, but it's nice. Now here's a summary slide, because to really go into the details of the evidence base for the therapeutic potential of psychedelics would require a talk in itself. But let's focus on a kind of overview, because I think it works in this context. The safety profile, first of all, with psychedelics appears to be positive in the sense that these aren't addictive compounds. It's often a question I get asked at the end of talks, and it's an easy one to address. Do people become addicted to psychedelic? Well, they don't. Animals don't self-administer. In fact, they're aversive, and humans, they don't repeat dose. Often they'll go months, years, not having a psychedelic experience. Toxicity, very low. You compare that with other compounds that are used medicinally, like ketamine, much higher toxicity. Alcohol, very much integrated in most Western societies, much higher toxicity for the brain and the body than there is with, at least with psilocybin. Work in healthy volunteers out at the Hopkins lab and others showing lasting improvements in psychological well-being after a single experience with psilocybin. Population studies showing that psychedelics are an anomaly among drugs of potential misuse, in that those who have taken them actually have better indices of mental health than those who haven't. That's an anomaly because generally the rule is the more you take of a given drug, the worse your mental health. So psychedelics, and it's worth drilling home this point because it may well be important, break that rule. Those who've taken them seem to have lower rates of psychological distress and lower rates of suicidality. That's a population study of 200,000 people in the US, Hendricks et al. OCD, an early pilot study, that was really the first of what's followed since in terms of clinical trials with psychedelics in this modern renaissance, showing some positive findings there, albeit a very small sample. All these studies are small samples, they're starting to get a bit bigger, but these are still, for all, in essence, these are small feasibility studies that are just suggesting that there's considerable potential here. But end-of-life distress, Hopkins and NYU and Charlie Grove, 3 different studies in this era showing improvements there. Peter Gasser showing improvements with LSD, the others with psilocybin. Addiction, alcohol dependence, Michael Bogenschutz. Matt Johnson looking at smoking addiction. Really impressive results there. 80% abstinence rates over 6 months on from 2 treatment sessions with psilocybin. We've looked at treatment-resistant depression and found these drops here. Quite rapid drops, that's at 1 week, the resolution's poor. And they seem to be relatively sustained, going on at least at 3 months, large effect sizes. Others looking at ayahuasca and depression showing improvements there. So there's something interesting, there's signal here, so it seems. We'll unpack some of the nuances, but nevertheless, it's hard to argue that these findings aren't at least interesting, and I think it's fair to say quite impressive. Also, the generality of the effect, that it's kind of challenging this precision medicine model of mental health and mental ill health, that you could try and find a specific molecule for a specific target, a specific biomarker. You could go in with your magic bullet and solve it, and hey presto, everything's wonderful. Psychedelics really challenge that model, and I would argue that it's a good thing that they do, because maybe the model isn't bringing the required changes in terms of mental health care. Now major investments coming in, several millions of dollars, funding a multi-site trial in Europe and the US, guided by the advice of the European Medicines Agency. I sat in on that meeting. It was felt quite a milestone, and also the FDA. So a trial across Europe, I think 9 or 10 different countries, and also now US and Canada, a trial as well. A company called Compass Pathways that are driving that work. So things are really happening, and it's also worth saying that major players in European and American academic psychiatry are on board. You have the former head of the National Institute of Mental Health, Tom Insel. He's now actually a investor in Compass. You have Guy Goodwin, former head of the European Psychiatric Association, Paul Summerberg, former head of the American Psychiatric Association. They're all advisors on this trial, so the mainstream are on board. Things are certainly seeming to mainstream at the moment, so things are happening. So this key question is where I'll go for the remainder, which is what are the therapeutic mechanisms? We talk more broadly about the pharmacology, about the brain imaging results with psychedelics. What about the therapeutic mechanisms? How, conceivably, could psychedelics work for these different disorders? I've talked about that possibility that there is a common underlying mechanism. So what are the candidate possibilities that relate to that principle? A bit of text on this slide, so let's try and break it down. It's this principle that's really born out of what our patients were telling us, that the treatment, and it should be described as a treatment because it's not just a drug and it's not just psychotherapy, it's this interesting synergistic combination of the two. But they'll say things like, afterwards I allowed myself to experience everything, even if it is sadness, so they could sit with even difficult emotion. But they would also refer to this reset feeling, and this would come up in sometimes different terms like reboot. This person saying it was like when you defrag the hard drive on your computer, everything could work sort of normally again. And this is this particular reset analogy you'll see in the context of efforts to try and understand what electroconvulsive therapy does in terms of its therapeutic mechanisms. Again, something that's not fully understood, yet its efficacy is very impressive in terms of depression, despite all the complications that come with it, potential side effects. But it seems to work well, at least in the sort of shorter term. Yeah. Also, we've looked at how the amygdala responds to emotion post-treatment, and we found something anomalous that actually goes in the opposite direction to what you see with conventional antidepressants, where the amygdala becomes less responsive to particularly negative emotions. That seems to characterize well SSRIs in general, chronic medication strategies for depression. But psychedelics do something opposite. The amygdala becomes more responsive to emotional stimuli in general, and also the contrast of fear versus neutral was bigger post-treatment, bigger response in the amygdala post-treatment. Now that might worry you if we didn't find that the treatment response correlated with this effect. So it's a very challenging finding, suggesting that psychedelics, in terms of this particular treatment model, work in a very different way, if not an opposite way to some extent, to conventional antidepressant treatment strategies. What else do we have to lean on that isn't necessarily psychedelic-centric, that allow us to understand the therapeutic mechanisms? Well, this notion of quantum change, and there's nothing pseudo-scientific here, it's just the idea of a sudden and dramatic change. It's a principle that we accept very readily when we think of negative change, and I'm speaking here about trauma having long-term consequences. but we're less ready to accept the possibility that people can have sudden dramatic experiences that have long-term positive effects on our mental health. But this is this notion here, and it's been written about by the likes of Diana Foscher, who has shaped a particular therapeutic approach in terms of trying to promote these accelerated experiential dynamic therapies. So it's psychodynamic in nature, but it's trying to accelerate some of the key cathartic processes and intensify the transference that ordinarily is there in dynamic therapy, but can take sometimes years to play out, and however many sessions, the kind of thing that isn't feasibly available for people at scale. And so, maybe there's an alternative here in the form of catalyzing and chemically driving conditions for more intensive psychotherapeutic work. Why might we not do that, and why we question it? Well, there are things around the importance of building trust, building therapeutic alliance, and also doing integration work afterwards, where you don't just have this profound transformative experience, but you also have the opportunity to make sense of it and to integrate it into everyday life. So that component of this treatment model could be critical as this goes on and develops. How am I doing for time? Okay, really? All right, well, we are making good progress. Let's now go on to this, which is kind of a work in progress, but I think it's important, which is how does this way of thinking how psychedelics work on the brain, and more generally, perhaps this entropic brain idea that there is an intimate relationship between complexity or richness of brain activity and richness of conscious experience. How can we mesh that with arguably the leading model of how the brain works, the Bayesian brain model, promoted and written about much by the likes of Carl Friston? How can we mesh these two together? And I think it may be quite a natural marriage, actually. What is the Bayesian brain? Well, it's this principle that the mind functions as a prediction machine. It navigates the world in a way that it does most of its processing through prediction. It isn't driven so much by sensory input, but rather driven on a much larger scale by our prior assumptions, knowledge, and predictions, and that can be demonstrated in a number of different ways, but a nice intuitive way to demonstrate it is to show optical illusions, where we see, for example, a white triangle in the middle that doesn't actually exist, yet our brains see it because that's the way our brains work. So how do we mesh this? Well, if we think of psychedelics moving the brain from its ordinarily ordered state into this entropic hot state, if you want, then naturally, by implication, that might be accompanied by a relaxation, if not a collapse, of our assumptions and our beliefs, at least at one level of the hierarchy, if not at multiple. And this is something that will come out in the wash. I know this is getting quite complicated, but I think it's worth introducing it because it could end up being very important. So what's happening here? You're taking that cool system, you're heating it with a psychedelic in a metaphorical sense, but also in some sense, kind of literally in terms of creating complexity, more entropy, and then afterwards the drug's washed out and the brain finds order again. And that sits very nicely both with the notion of a flattening of assumptions and beliefs, predictions, creating the opportunity for revising them, and a process of reset as the brain comes back to organization and order. And what I just said is sort of summarized here. Let's focus, though, on the way of understanding the brain and depicting brain function as a hierarchical system. Let's do that by thinking about the visual system that has bits concerned with low-level features of the visual sensorium, and then as you go up the hierarchy, you have modules that are more important for context and sort of richer aspects of visual experience. So this principle that's nicely characterized in the visual system is true of the brain in general, it seems. And then this key question, at what level do psychedelics collapse beliefs, and a kind of working hypothesis that perhaps it is at this high level, particularly at the high level aspect. So beliefs like that we are absolute selves and egos and always existed, yet under a psychedelic, like in meditative states, can be revealed to be somewhat illusory. And then what happens when you collapse the highest level of the hierarchy? What implications does that have for lower levels? Perhaps it means that those lower levels can sort of spill out and confer influence in a freer way than ordinarily they might. And so you might characterize this as an anarchic mind or an anarchic brain, revealing things that are ordinarily suppressed out or inhibited out of consciousness. I put in this reference because we've heard quite a bit about politics and psychedelics today, and we're not the only team that recently have shown that psychedelics appear to modulate belief systems, and we've looked at liberalism and authoritarianism. We've seen liberalism increasing with psychedelic use, authoritarianism decreasing. We see nature-relatedness increasing, and others have as well, nature-connectedness. And so speaking to this idea that's quite frightening, I think, for some people, and if you want to get a bit conspiratorial about why psychedelic science was suppressed, then you might think maybe it has something to do with the fact that the idea that psychedelics are hippifying, so to speak, that generate hippies. It's not just that hippies take psychedelics create hippies. May well have some substance to it, and what are the implications of that? We'll find out as we go on. So this context-sensitive principle is key when it comes to psychedelics. It's why, you know, when I give these talks, and it all sounds quite interesting and I hope and positive in terms of psychedelics and mental health. You know, I try and emphasize the caveat that the model here is kind of at least really two key components. One of a chemical change that then creates the conditions for increased sensitivity to context. That context can be the environment, the people that are with you. It can be the music that you listen to. But it can also be what's within the inner context, set and setting, and how these things can't be extricated, can't be pulled out of the therapeutic model. They're an essential part of it. We can test that. It's a challenge, but maybe we could do it in a 2x2 design with lower doses, where it's not so ethically questionable to provide an unenriched context and give a psychedelic. So it is possible to test that. We just have to be careful in doing so. Now, can I revise the time question? Because I've probably got about four slides left. Is that okay?
Would be a pity not to listen to you, please.
Okay. So criticality. In a way, this is I gave you principles of disintegration, desegregation, and entropic brain. If there's another principle that could be really important in terms of our understanding of what psychedelics do to the brain, but more importantly, how the brain works in general, it may well be criticality. And people have written about how the brain is critical already and demonstrated it in humans and other animals. How does it fit in this context? And it fits in. First of all, what is criticality? Well, it's a critical point, hence criticality. It's a kind of sweet spot or Goldilocks zone, as has been said, in between two extremes of a frozen system that is too ordered, such that it has no dynamics. It's very ordered, but it has no dynamics, so it can't adapt in any way. Or at the other extreme, an entirely dispersed, chaotic system that can't preserve anything because it's just might be highly dynamic, but it has no order, no form at all. And so there's a sweet spot in between these two, which is, so well characterized by the living world, by nature, and the brain, lo and behold, as we would expect, exhibits criticality. What characteristics exist of criticality? There are some important signatures. One of them that I'll focus on is maximal sensitivity to perturbation. What does that mean? It means if you take a system, whatever it is, and you do something to it, your effect on that system will have greater reverberating effects in a critical system. If the system was too dispersed, it just wouldn't register your effect. If it was frozen, it would just ping straight back, and again, it wouldn't register any effect. So maximal effect of perturbation at criticality. This could easily relate to the principle that the mind and the brain, it's the mind we know, is so sensitive to context under psychedelics. If it is true, as we've recently found, collaborating with researchers from Barcelona, Gustavo Deco's team, that the brain under psychedelics shows enhanced signatures of criticality. This principle that characterizes the natural world is more pronounced in the psychedelic state than it is in normal waking consciousness. I think that's quite exciting. What it means, I don't know. We can speculate that maybe some of these hippie phrases like that psychedelics make you feel connected to nature, more connected to things, more in harmony with nature, perhaps do have some kind of foundation in this world, in this natural world, and don't require any sort of pseudoscientific leaps into, other spaces. This is more or less where I'm going to sort of bring things down to a close. There's a lot of text, but what's it saying? And it's really about the principle that is captured by the very term psychedelics, mind revealing, that this is a hypothesis really. It's a belief, as hypotheses are, that needs to be better tested. Personally, it's a hypothesis that I would place a bet on. I think it's solid. I think that we could demonstrate, good empirical evidence to support the idea that psychedelics do indeed reveal more of the mind than is ordinarily available to conscious access. But it needs to be tested. This comes into this idea of whether the insights that people report on psychedelics are veridical, meaning are they real? Are these real insights? If someone says, I had a memory, a flashback that I was abused in my childhood under a high dose of LSD, for example, how confident can we feel that that is a true reliving of this traumatic event or something of imagination? That's an extreme example, but it's a principle that's important. How well can we trust these insights? There's kind of two parts to this slide, and the second part relates to a kind of potential pitfall of the therapeutic use of psychedelics and also the recreational use, if not more so actually, recreational use, which is this notion of spiritual bypassing. And I should say it's most likely to be an exception rather than the rule, but it's this idea, which may be an observation, we're going to test it, that psychedelics can, in some cases, like I said, an exception, lead to people kind of leapfrogging some of the personal work that they might do, for example, in psychodynamic psychotherapy, and sort of become messianic with psychedelics and start saying, they connect me to, Martin was talking about this a bit at the start, I think, about some of the sort of pseudoscience that can come in around psychedelics, his ideas of connecting to an energy force. Is there something going on there that might be escapist rather than really processing first personal personal stuff and really integrating the mind before, you know, claiming to be an enlightened being who's transcended their ego, for example. So what kind of explanations could, you know, such inferences give us? Well, they could give us explanations that make us feel good, but I would submit the idea that at least in some cases, if they're not grounded, they may give us inferences that are fallible, that are vulnerable, that are fragile, and so, you know, if you haven't done the personal work, maybe in time, you know, even though you might feel good for a week or two after the psychedelics, in a way you'll be found out, you know. And so it's just, again, speaking to this the importance of integration work, of staying grounded with psychedelics, that will be so true with the therapeutic work, but it, of course, also extends to the fact that so many people take psychedelics outside of the context of formal psychotherapy. Now, closing, what can we sort of take home? I've talked about these ideas of an entropic brain state conferring some functional advantages in terms of being more supple, able to learn in the same way that an infant can, like sort of, you know, Martin's work and Alison around relaxed priors and how that might sometimes confer some cognitive advantages in terms of a broad hypothesis search, not being too influenced by overweighted prior assumptions. And infants, of course, demonstrate this so well. This is actually my son. Heaven lies about us in our infancy, from William Wordsworth. And now we can think of ontogeny, but we can also reflect on phylogeny, as the likes of Terence McKenna has, and his famous stoned ape theory, which is the idea that the ingestion of psychedelic plants, I think specifically mushrooms, drove the evolution of human consciousness. An idea that you know, some people might chuckle about, but a lot of people are really captivated by this idea, and of course it's really interesting. But of course, you know, is it true? And maybe in keeping with the principle of Occam's razor of trying to find the simplest explanation for a thing, the most plausible, maybe there's another possibility. And maybe there is a possibility that the functional architecture that psychedelics hijack and stimulate, it could be said to some extent in an unnatural way, is there for fundamental change. Psychedelics can do that. They can come in, you combine it with a therapeutic context, and it can be not just good for you, it can be, you know, truly a lifeline. But why is it there? And maybe it's there. We talked about stress, we talked about environmental volatility driving stress. Maybe it's there for transformative change, for sudden change when change is really needed. I think that's a more sober possibility. I think it's worth one reflecting on. Quite how we'll test it is a difficult question, but maybe something to reflect on. What are we doing next? We'll, in some sense, put our money where our mouth is and test whether psilocybin specifically, test how well it matches up to conventional treatments in psychiatry. Here, I'm telling you about our next trial, which is psilocybin 2 treatment sessions in the blue corner for major depressive disorder versus 6 weeks of daily escitalopram going up to 20 milligrams for the final 3 weeks. So certainly giving escitalopram a fair crack of the whip. I think we're giving psilocybin a fair chance too. So let's see what wins out. We're balancing everything in this condition. Maybe edit this out of the video for anyone who might volunteer. You would get 2 treatment sessions with, let's just say, a very low dose of psilocybin. And in this condition, people take 6 weeks of daily placebo in a placebo. So everything's matched. We'll look at things like expectation, therapeutic alliance, all the potential things that people might consider confounders, but may just be important variables. And we'll test our assumptions and see how psychedelics match up. We're bringing it to a close now. So, you know, a lot of these ideas aren't so new. Everything that seems new is often turns out to be borrowed, and that's just the way it is. So this idea of a mental recalibration or a reset isn't a new idea. You'll find it when people think about the therapeutic mechanisms of ECT and now ketamine as well that show promise for depression. Drug-assisted psychotherapy, it's not a new thing. People have explored glutamatergic drugs and others to see whether they can assist psychotherapy, but not really with much signal there. Maybe psychedelics can change that. And neither, of course, is psychedelic therapy a new thing, given that certain cultures have been doing this for hundreds of years, maybe millennia. And what does that tell us? Well, maybe it suggests that sometimes you do need to go backwards to go forwards, and in the context of psychedelic therapy, maybe bring that human element, much needed human element, back into psychiatry. Thank you very much.